Straighten and edit by curve. In this video, we'll use straighten and we'll use edit by curve. In Fusion 360, we want to get started with the supplied dataset form edit by curve. This form body was a cylinder that has a lot of different twists and bumps in it. We want to take a look at some of the tools that we can use to help smooth this out and get it back to a more perfect shape. The first thing that we want to take a look at is using straighten. When we take a look at straighten, we have a couple different direction options and we have some straighten types. We're going to be using control point as we've already seen the difference between control and surface points. So we're going to focus our attention on those control points. Let's go ahead and take a look at T-spline vertices. And we want to begin by selecting some vertices and just seeing what happens. If we include the vertices all the way at the top and the bottom, you can see that we're getting closer to a straight line, but it does still have a lot of twists. If we work our way around and we begin selecting other vertices, you can see that it's starting to pull those together, and this becomes problematic. Note that we do have some extra control points on the top and the bottom, and we also have this option that allows us to select a range of vertices. This will allow us to increase or decrease our selection. But note that this does a pretty good job of allowing us to straighten, but we do have some other options. This fit method just takes an average, but if we use a selected line, a selected parallel line, or selected 2 points, we can have some further control. I'm going to use the 2-point method, and I'm going to select the start and the end points, and then I'm going to select the T-spline vertices that I want to pull to that line. Once again, it's taking an average, and it's not a perfect solution, but it does give us a better representation. If we rotate this around, we can see that a yellow line is created, and it is pulling those vertices out. If we say OK and we repeat this process, once again by using the selected 2 points, we're going to select the upper and the lower points, and we'll select the vertices that are in line with those points. By working our way around, you can see that we can use this tool to get a little bit closer to that original shape. It is going to take a little bit of work, but with a few attempts and a few tries, we can smooth out a portion of the cylinder, and then we can use something like cylindrical symmetry to help pull the rest in line. So after just doing 3, you can see that we have a much better result, where if we look at the other side, how it was originally designed, you can see that those 2 sides are very different in the way that they're shaped. Next, let's take a look at another tool, and this is called Edit by Curve. Edit by Curve is extremely helpful, and it allows us to take a look at modifying specific edges and adjusting them based on a degree. What we're going to do is we're going to make some edge selections on some of the edges that we just straightened. And notice that after I select a few, let's go ahead and restart that selection and go from the top to the bottom. Notice that as soon as I make that second or third selection, it begins adding these control points. When I select a control point, I am able to move it using my manipulator, and I can begin adjusting the geometry based on that. Let's rotate around to a back view, and you can see here that we can begin pulling these edges out, and we can essentially create a spline that can help us control that geometry. It is important to note that this is essentially using a Bezier curve underneath, and the degrees that we use are going to dictate the number of control points that we have. And again, we are pulling to the underlying curve. Very similar to how we have control points and surface points on our T-spline body, we have control points on the curve, and then we have the surface points that are being pulled or controlled. Also note that we do have options for uniform or edge length distribution. We can also make a planar curve, and again, we can determine whether or not we want to use control points or surface points to actually control the underlying geometry. So once again, this edit by curve is a great way for us to manipulate our geometry and smooth it out. Because oftentimes when we get the results from a generative design study, we have a lot of deformity that happens in those results because they are idealized based on the simulation and the mesh density. If we have a higher mesh density, likely we're going to get a smoother result overall, but we'll have a lot of those micro things that we need to take care of. If we have a lower mesh density, the resolution on the mesh is going to be much smaller, but overall we'll have less things to control. So there is always going to be a give and take in the setup of these generative designs and the outcomes that we get from them. But by using and exploring these form tools on basic examples, it'll help you better understand the ways in which you can use them on those more complex examples. From here, let's make sure that we do save this design before moving on to some of the practices and challenges associated with the course.